All right, ladies and gentlemen, we did page 1 of this notes together in class, so now we're going to finish up with this lesson, looking at our proportional relationship. So here's an example. So we have Paul walks 2 miles in 25 minutes. How many miles can Paul walk in 137.5 minutes? So fill in the table below to help you determine the answer. So if I keep, and I just am going to keep going up here, so I have 25 minutes, it was 2 miles, so that means in 50 minutes it was 4, and in 75 minutes it was 6, and in 100 minutes it was 8, and 125 it was 10, and 150 it was 12. So I know it's going to be somewhere in between 10 and 12. All right, so is the relationship proportional? Yes. How do I know that? It has a constant rate of change. Right, so constant rate of change, it's going up here, it keeps going up by 2's, and over here it keeps going up by 25's. So find the constant of proportionality, K. Well, that's where I'm going to do distance, how much is it going up by, over how much is it going up by in y's, right? It's going up by 2's in y's over 25 in the x's. Use the constant of proportionality to write an equation. So my general form, remember, is y equals kx. In this case, though, we're using distance. This is your y and this is your x. So I'm going to rewrite it using distance and time. So distance, which is the y, is 225, my constant of proportionality, times time. All right, use the equation to determine the number of miles Paul could walk. So now we know it needs to be somewhere in between 10 and 12. So here's your t. So we're going to start with our equation. I'm going to replace t with 137.5, and that should give me, I did this on my calculator, 11 miles. Okay, all right, next one. Wesley walks at a constant, so Wesley walks at a constant speed from his house to school, 1.5 miles away. It took him 25 minutes to get there. So what is his constant of proportionality? So this is the distance, 1.5 over 25 minutes. I'm going to divide that out. That actually gives me 0.06 miles per minute. You could keep it as a fraction. I did that in the first one. This one I'm turning into a decimal. Use Leslie's constant to write a linear equation. So again, our formula, y equals kx. This time they're telling me to use y and x. So we're going to have y equals 0.06x. We did all this last year. Use your equation to determine how many miles he can walk in 15 minutes. That's your x. So y equals 0.06 times 15. And that turns out to be 0.9 miles. And I did that on my calculator. All right, next page. Stephanie drove at a constant speed of 35 miles per hour. This right here, that is your K. If she drives for y miles and it takes her x hours, write a two-variable equation to represent how many miles. So they're just asking us to do what we were doing before. So y equals kx. I know k is 35, so y equals 35x. Assuming she drives an entire time, how long will it take her? So 15 miles away, this is y. So we're going to put in 15 equals 35x. Divide both sides by 35. And when I do that on my calculator, right, so 15 divided by 35 is going to give me about 0.43 out of an hour. Okay. It took Dave 55 minutes to travel 12 miles. Assuming Dave travels at a constant speed, write an equation. So y equals, I have to first figure out what k is. So we're going to do 12 over 55. So 12 divided by 55 is going to be 0.218 repeating miles per minute. So 0.218x. All right, now let's fill it in here. Use the equation to complete the table. round all answers to the nearest hundredths place. So 15 minutes, so we're going to have 0.218 times 15. So 0.218. And if you wanted to keep it as a 3.27, if you wanted to keep this as a fraction, you certainly could do that. So 0.218 times 30 should be 6.54. 0.218 times 45 is going to give you 9.81, and then 0.218 times 60 and 0.218 times 75 is going to be 16.35. Alright, so it's about being able to find the constant of proportionality and then being able to put it and fill it into the equation and then using the equation. All review stuff from last year. But if you have any questions, bring them with you to class. Have a good night.